16代目のクラウン、日本の歴史に重ね合わせれば、それは明治維新です。ご覧ください。新しい時代の幕開けです。
There are continuous rumblings of the future of the automotive industry, electric vehicles, petroleum combustion engines, hydrogen fuel cells. All of these forms may have their days numbered if Toyota's recent announcements are to be believed. Toyota has been conducting deep research into an engine that would upend the entire industry, including their own hydrogen fuel cell vehicles, in a pivot that will seemingly revolutionize the way that we look at engines. A water-cooled hydrogen combustion-based engine that would serve as the pinnacle of eco-friendly engineering has emerged, and it runs at 2,500 degrees Celsius using an inline 6-cylinder internal combustion engine. This may sound a bit like science fiction, but Toyota has been known for pushing the boundaries of vehicle technology and engine efficiency. The Toyota Mirai and its 1.6-litre hydrogen 3-cylinder engine has been at the forefront of the hydrogen conversation since its debut in 2015. But what is this new engine, and how will the concept of a water and hydrogen-powered engine break through the barriers of legacy combustion technology? Welcome to Future Scout. Today we're popping open the hood to learn more about Toyota's new water engine. Don't forget to like and subscribe, and let's dive in. Water engines have been an aspiration of automotive experts and manufacturers for decades. Toyota themselves have been at the forefront of this research since the early 1990s. And in 2015, when Toyota released their first attempt at creating a mainstream hydrogen vehicle, they debuted the Toyota Mirai. So while the concept is not new and the production hydrogen models are about a decade into availability, there has been an extreme range of experiments striving to create a water engine, from academic exercises to low-budget garage experiments. No major automaker has come close to succeeding in producing a water-powered engine that's practical and ready for mass production, but that is not stopping Toyota. Toyota's R&D budget is reported to be a staggering $9.1 billion, with world-class engineering and manufacturing capabilities. Of all the automakers, they are likely the best equipped to bring this to the market from their experience in the space and the way the company continuously pushes boundaries on sustainability. So how exactly does this potentially revolutionary engine work? By transcending existing fuel technologies, it uses a double injection to pump water-cooled hydrogen into its cylinders. Unlike traditional liquid-stored hydrogen vehicles that use high-pressure storage tanks and liquid hydrogen, this approach relies on conventional engine technology, meaning the shift requires far less effort than one would expect. The new engine takes a far different approach to hydrogen as well. At present, the overwhelming majority of hydrogen engines are air-cooled, but Toyota has opted for a water-cooling hydrogen technology in the combustion engine that changes the game. The chemical properties of hydrogen combustion cause a huge spike in air temperature, up to 2,500 degrees Celsius. Toyota is heavily betting on this water-cooled technology as the next evolution of the combustion engine. This will allow it to cool the engine block and cylinder head through circulating water, which will then carry vast quantities of heat from the combustion chambers, which are normally some of the hottest components in an engine. The use of water cooling enables the engine components to consist of aluminum rather than steel, which will drastically reduce the overall vehicle weight. This will grant higher efficiency and allow the engine to rev higher than a petroleum combustion engine, igniting the possibilities for faster and potentially more exciting race cars as well. In fact, Toyota has been testing this concept in the Super Taikyu endurance races in Japan. In 2022, the company entered its Corolla H2, which uses the water-cooled hydrogen combustion engine, and within one season of competition, the engineering team managed to increase the combustion power by a whopping 24%. The car's torque increased by 33% and the range increased by 30%. This also helped cut the refuel time down from 5 minutes down to 90 seconds. And with a more compact and lightweight design in the water engine, hydrogen can flow directly into a combustion chamber where it ignites, similar to the process of a natural gas engine. This marvel of engineering would allow for bountiful fuel and could completely eliminate the need for petroleum gas stations if the technology reaches mass scale in production. This means that Toyota's new invention could physically influence the urban landscape that automobiles commonly drive within due to this breakthrough. But how is this engine non-polluting? Because these engines will run at 2500 degrees Celsius, they grant greater combustion and thermal efficiency, which burns off pollutants compared to traditional engines that run a lot cooler and output carbon monoxide. This carbon monoxide later bonds with oxygen molecules in the atmosphere to create carbon dioxide, which causes the greenhouse effect, trapping more of the sun's heat within the Earth's atmosphere, thus warming the planet. With virtually zero emissions, this new water-cooled hydrogen engine will serve as a rival to zero-emission tech and electric vehicles, sidestepping the need to mine rare earth elements such as lithium, cobalt, nickel, and others which complicate vehicle supply chains and have their own environmental impact. But it's not just Toyota. Other manufacturers are starting to see the potential here as well. Toyota has even partnered with Yamaha to create a hydrogen-powered V8 engine. This is intended to be a 5.0-liter V8 based on the one used by the Lexus RC Coupe. The cylinder head and fuel injectors would have modifications, and Yamaha claims that this engine can produce 455 horsepower at 6,800 RPM and 398 pound-feet of torque at 3,600 RPMs. Compared to its inspiration, this is a bit less powerful, but comparable with its outputs, and without the emissions to boot. Based on the increased performance the Toyota team had with its H2 Corolla, it's only a matter of time until the hydrogen engines have a baseline performance that outperforms their petroleum counterparts. With engines like this in the works, rare earth metals that pollute water sources and oil mining disasters may become a thing of the past from this earth-altering approach. Toyota may be on the precipice of striking metaphorical gold here as well, because if they manage to create and operate the hydrogen infrastructure for these engines, that will mean they can also charge reasonably low rates on an incredibly high-margin fuel that is not expensive to create, transport, or store. This would undoubtedly create clean energy jobs that would help offset the paradigm shift of moving off of dirty energy. Hydrogen is seen by many as the future of vehicles, and for good reason. It is the most bountiful element in the entire universe, and the fuel that stars fuse to ignite into enormous balls of fire. The fuel itself is also able to withstand temperatures as low as negative 239 degrees Celsius or negative 435 degrees Fahrenheit. This opens the door for hydrogen internal combustion engines to be used in freezing climates where engines have a hard time functioning due to the freezing effect of double-digit negative temperatures. But as we've mentioned, there are numerous challenges that impede the widespread adoption of hydrogen due to logistics and safety challenges. While water engines may sound overly futuristic and utopian, they will likely serve as the bridge to a new way of fueling our transportation. They will be extremely practical and can easily see their applications shift to other vehicles such as buses, large semi-trucks, and potentially even aircrafts and marine vessels. Like we previously mentioned with the Corolla H2 and Yamaha collaboration, these engines are not lacking in power. They can easily be on par with the performance of conventional petroleum fuel vehicles, with the potential to generate 3 times the energy compared to gasoline counterparts when taking into account the megajoule output of the fuel ignition. We may even see faster transportation methods surface across land, sea, and air. And with more potential energy, but far less risk for fire and explosions, the mechanical designs of these hydrogen-powered combustion engines will provide a consumer feel that is a good option and far easier on their wallets to help loosen the grip that the oil industry holds on society. The simplicity of these engines makes them far more efficient and simple to produce than electric vehicle batteries, and could help kickstart manufacturing in other still developing countries with limited oil resources. And oil-dependent countries may find this breakthrough to be a threat, but in fact an Iranian scientist by the name of Aladdin Qasimi successfully converted his Puget 405 to run on water. This successfully demonstrated just how feasible water and hydrogen-powered engines can actually be. He did this without the multi-billion-dollar R&D backing that Toyota engineers have, and not only that, But Cassini's estimated range for this conversion was 30 to 40 miles per gallon, or 48 to 64 kilometers for every 3.8 liters of water. When compared to the unmodified version of the Puget 405, this indicated an increase in fuel efficiency. With proper engineering, water-cooled hydrogen-powered cars might be able to improve efficiency to scales we had not even comprehended, especially considering that the technology is very much in its infancy and is not even publicly available yet. There does seem to be a very promising future ahead of this technology, but obvious challenges will present themselves. One such challenge is political lobbying and maneuvering from large oil companies and others with a vested interest who seem hell-bent on continuing their agenda at the expense of the planet and all of us who inhabit it. Water-cooled hydrogen will reduce the likelihood of accidental explosions and improve public perception regarding the safety of this fuel type. For example, you would likely never see a car running on water engines ignite after an accident due to the lack of petroleum and other potential chemicals that this engine could eliminate the need for entirely. Imagine a world where the likelihood of your vehicle breaking down has been drastically reduced, and you are able to drive wherever you want, knowing full well that you won't have to stop and charge your vehicle or get gasoline. The new hydrogen combustion engines truly seem to be on the verge of making this closer to reality. And once these engines become ready for production, you can bet that we will be in line to purchase one for ourselves. Thank you for watching Future Scout. Don't forget to like and subscribe and leave a comment to let us know what you think of these breakthroughs. We'll see you next time.